Hello and welcome. This is Module 3 of the tutorial Elementary Programming Principles. In the previous tutorial, we discussed the types of high-level languages, and we classified them into 5 different groups, namely third-generation languages, or what we call structured or procedural languages, fourth-generation languages, the 4GLs, fifth-generation languages, the 5GLs, and object-oriented programming languages. Now, in this module, we will start by discussing the fourth-generation languages, or the 4GLs. "4GL" makes programming even easier than the 3GLs because they present the programmer with more programming tools, such as command buttons, forms, text boxes, etc. The programmer simply selects graphical objects called controls on the screen and then uses them to create designs on a form by dragging a mouse pointer. The languages also use application generators, which in the background generate the necessary program codes. Hence, the programmer is freed from the tedious work of writing the code. 4GLs are used to inquire and access the data stored in database systems, and hence they are described as the query languages. So in our previous module, we discussed the 3GLs, and we said that it belongs to the high-level languages which were developed to resolve the problems that were encountered in the low-level languages. And at this moment, we are saying that the 4GLs even makes programming easier because it presents the programmer with what we are calling programming tools, which will work as buttons. So the programmer will just be required to know what he or she wants to do, and he will apply the necessary commands. He will drag the necessary forms. He will write whatever he is required to write in the various text boxes that are provided. So the programmer doesn't have to have all those skills. He just required to have the basic skills, and he or she can get started. We're also saying that the 4GLs are also used to access data stored in database systems. So you find that in what we'll be calling web scripting programs like the PHP and the rest, and also the ones that are used in Microsoft Access, you find that there are programs that can be used to access databases, or that can be used to access data stored in database systems, and for that reason they are usually described as query languages, because they usually query the database for some information. They usually get some information from the database, and the information may be used by the user to make various decisions. The purpose of fourth generation languages. The fourth generation languages were designed to meet the following objectives. 1. To speed up the application building process, thereby increasing the productivity of a programmer. Earlier on, when we were discussing the low-level languages like the machine language, we said that they're usually tedious and usually time-consuming. And to overcome that, there was the purpose of coming up with other languages that will actually increase the productivity of a programmer. And that's why we had languages such as the 4GLs, which will reduce the application process and hence reducing, or rather increasing, the productivity of a programmer. The other purpose of fourth generation languages is to enable quick and easy amendments and alteration of programs. Basically what we are seeing here is that the 4GLs are just meant to resolve the problems that were encountered in low-level languages, whereby you find again that amendments or the review of programs was almost next to impossible. But again, now you find with the 4GL languages, they will actually not just allow amendments, but it will be quick and easy. The last purpose of 4th generation languages is to reduce the development and maintenance cost. So you find that because these languages will be using vocabulary that is close to English, developing will be a bit easy, and also to maintain, because you find that making alterations, finding the errors in the program statements becomes easy, and hence now the maintenance cost will also be lowered. What are the examples of 4GLs, or the 4th generation languages? They include the Visual Basic. If you're learning, or if you'll be learning these languages, they belong to the 4GLs, and they are almost some of the recent ones. Delphi Pascal, Visual COBOL or Object COBOL, and Access Basic. So we also send that these languages are also called query languages, because they are used to get information from database systems, and as we all know, Access is basically a database. What are some of the advantages of 4th generation languages? One is that they are user based, and therefore they are easy to learn and understand. So as we said when we were beginning, is that these languages will use commands. They will also use forms. They will also use text boxes that the user just need to drag and drop, and hence we say it is user based, and it will become easy to learn. The user doesn't have to understand how the computer works. He'll just be required to know what he or she wants the program to do, and he will apply the necessary commands while programming. The grammar of 4GLs is very close to the natural English language. It uses menus and prompts to guide unknown specialists to retrieve data with ease. Again, as I mentioned, is that you don't require a lot of skills in programming with these programming languages, because one, it will use a language that is close to the natural English that we are used to. Again, it will have menus. Of course, these menus will have commands that you can apply based on what you want to do. It will also have prompts that will guide non-specialists to retrieve data with ease. So you find that the languages themselves are user based, and they are also helping the user to do what is required, or to guide him or her on what is supposed to be done at a certain point. Another advantage is that very little training is required in order to develop and use 4GL programs. So again, as you've said, because these languages will have menus, it will have prompts that will be guiding a non-specialist, you find that very little training is required, because everything is like on the screen. You just required to be guided on where to find what, and it becomes now easy to get started. You also find that the other advantage is that they will provide features for formatting of input, processing, and instant reporting. So as we said, these programs are user based, and they will have commands, they will have text boxes, they will have forms, and other features that will help the user in formatting the inputs, the processing, and having to report instantly. So those are the advantages of fourth generation languages. You can try to look for more advantages of the fourth generation languages and also try to use them. Moving on, we will now discuss the fifth generation languages, the 5GLs. The 5GLs are designed to make a computer solve a problem by portraying human-like intelligence. The languages are able to make a computer solve a problem for the programmer, hence he or she does not spend a lot of time in coping up with the solution. The programmer only thinks about what problem needs to be solved and what conditions needs to be met without worrying about how to solve or how to implement an algorithm to solve the problem. 5GLs or the 5GLs are mostly used in artificial intelligence, that is AI. So you find that these are the programs that are currently in use. They are actually the latest programming languages, and they are used in development of things like robots. They are used in scenarios where things needs to be automated. They are also used in scenarios where human-like intelligence is required. Like, you don't need to have a human being solving a certain problem. You can set a computer to just do that, just do like a human being will do, applying that human-like intelligence. So to make that happen, programs will be designed, and to help in this programming, a person will use these fifth generation languages. And examples of these fifth generation languages includes the Prolong, Lisp, Mercury, and Occam, that is OCCAM. So these are just examples of the fifth generation languages, which we've said that are mostly used in artificial intelligence, or the AI. And currently the AI is the one that is in the market. You find that AI is everywhere, and everything is like it's required to be automated, and that is actually building what we call unemployment. Alright, those are just fifth generation languages in a nutshell. So if you want to know more about them, you can as well just do some research. The other programming language is object oriented, or OOPS, that is OOPS. Object oriented programming is a new approach to software development in which data and procedures that operate on data are combined into one object. OOPS use objects. What is an object? Is usually a representation of a software entity, such as user-defined window or variable. Each object has a specific data values that are unique to it. These values are called state. Each object has a specific data value that are unique and a set of things it can accomplish, and these things that it can accomplish are called functions or behaviors. So what are we saying here? That object-oriented programming languages is actually a new approach in development of softwares, whereby data and procedures that are to be operated are combined into one object. So you find that data and procedures are combined into one object. And we've said that an object is a representation of a software entity, such as user defined window or variable. So each object will have specific data or values that are unique to it, and we've called them state. It will also have a set of things that it can accomplish that are called functions and behaviors. Several objects can be linked together to form a complete program. These programs send messages to an object to perform a procedure that it is already embedded in it. And this process of having data and functions that operate on the data with an object is called encapsulation. So it is that process of having data and functions that operate on the data within an object. So having the data and the functions that operate on that data within an object. So like combining the procedures, combining the data, combining all that is required into one thing that you are calling an object is what we are calling encapsulation. The data structure and behavior of an object is specified by a template. So the data structure and behavior of an object. So you said that the object-oriented programming will be using objects, and this will be a combination of data and procedures that data will operate on. And we are saying that the data structure and behavior of an object is all will be specified by what we are calling a template or class. So you can either call it a template or a class. So what will be defining the structure and behavior of an object is what we are calling a class. And classes are hierarchical, so they will be like in a certain order, and it is possible to pass the data and behavior of an object in one class down the hierarchy. Object-oriented programming enables rapid program development. Every object has properties such as color, size, data source, just mentioned it. And these properties can be set easily without much effort. So maybe as we read them here, as we discuss them here, it might seem a bit difficult, but maybe when it comes to application, when it comes to apply them, because everything is set, it becomes very easy. You also find that in addition, every object has events associated with it that can be used to trigger certain actions. For example, to remove the window from the screen, you can click the close button. So you find that in most of the programs that we used nowadays, or that we are using nowadays, is that if you want to close the window of a program, you'll just use the close button, mostly found on the right top part of your screen. And these are the objects that we are talking about, that everything that you require is in that window. It's like it is as we mentioned earlier, encapsulated. It is like combined into that window, and then you find that we'll have some events that can be moved down the hierarchy. So like for example, we are talking of those features that will trigger certain actions, such as removing a window, maybe dragging it from one point to another. So They are just events that are associated with the window and that will be triggering some specific actions. OOPS has contributed greatly to the development of graphical user interface operating systems and application programs. So, as we said, the operating systems that we use, the various programs that we use nowadays, they are usually programmed by programmers, and you find that most of the recent programs that we are using, most of them are graphical based. They are graphical user interface. So you find that you'll be using the GUI, whereby the user will be using a pointer to just point on various commands, to open things, to close them, and all that. And to make this possible, these softwares, these applications are designed using object-oriented programming languages, which will combine everything that is required, the procedures, the data, everything, into what we are calling an object. Examples of object-oriented programming languages will include C++, Simula, Java, Smalltalk, among others. Remember, Java is sometimes associated with development of websites. It can be used to create whole application programs that do not need a web browser to run. So you find that with some programs, they will run only on a web browser, but they cannot run on any other platform. So you find that we have this language that we call Java, that is mostly associated with development of websites, and websites, as you all know, will need a web browser to run. But still, Java can also be used to design programs that will not need a web browser to run. So it's like a sort of a wide language. Java is an object-oriented programming language that resembles Object-C. That is a simplified form of C++. The code of Java displays graphics, access the network, and interfaces with users via a set of capabilities known as classes. Classes define similar states and common methods for the behavior of an object. Java programs are not compiled into machine code. Instead, they are converted into a collection of bytes that represent the code of an abstract Java virtual machine, that is VM. A Java interpreter running on a physical machine is then used to translate these bytes into local actions, such as printing a string or drawing a button. So we'll be just talking about the Java language, which is an object-oriented programming language, and we're just saying that it displays graphics. It also used to access networks, and also has interfaces with users, or it links with users via a set of capabilities that are known as classes. So these classes usually define similar states and common methods for the behavior of a certain object. And something else to note here is that we've been talking about high-level programming languages, mostly using compilers and interpreters to translate the language into machine code. But you find with Java, they're not compiled into machine code, and instead we've said that they are converted into a collection of bytes that will represent the code for an abstract Java virtual machine, the VM, and thereafter a Java interpreter. So it's like there will be a specific language translator for this program language, the Java. So like a Java interpreter running on a physical machine is then used to translate those bytes into local actions, such as printing a string, among others. All right, so let's try to talk about web scripting languages a little bit. And web scripting languages are mostly used to create or add functionalities on web pages. And what are web pages? Web pages are used for creating websites on the internet where all sorts of advertising can be done. Web pages are hypertext, that is, they use plain text documents written using a language called hypertext markup language, HTML. HTML documents have a file extension of .html or .htm. Something good to note is that HTML does not have the declaration part and control structures, and has many limitations. Therefore, to develop functional websites, it must be used together with other web scripting languages like Java, that is JavaScript, VBS, that is VB script, and hypertext preprocessor, that is PHP. So we are saying that we have these languages that we call web scripting languages, and which are mostly used in designing or web development, that is, creating or designing websites. And you find that for you to have a website, it will be basically a combination of web pages. Like a website is made up of web pages. So what you'll be creating or designing is web pages that will now be combined to make, or that will be interlinked to make what we call a website. So website mostly will be uploaded on the internet, so that all sorts of stuff like advertising and all that can be done. And in web scripting, basically it will just involve plain text documents that will be written mostly in a language that we call HTML. Like to write web pages, you will use a basic language that we call HTML, that is mainly used to write just text or hypertext or plain text. So this language, HTML or hypertext markup language, will just help you to just write text, as I've mentioned, and the text written or the document that will be written with this language will be saved with an extension of HTML. So this will now make this document or this specific file to open with a web browser that will clearly display these web pages as they have been written. But something to note is that HTML is some sort of basic language, and it's not dynamic. So you find that for you to make sense or more sense out of your website or what you have designed, you require to include some other web scripting languages that will include control structures, that will like bring life into your website, so that your website is dynamic, so that you can be able to make changes easily, update the website easily, and so on and so forth. So you can include other web scripting languages such as Java. You can also include the hypertext preprocessor, that is PHP rather, that will make your website dynamic, that will make your website easy to update, and so on and so forth. Which are the factors that you'll have to consider when choosing a programming language rather? So we've discussed several programming languages, and now this means that you'll be confused on which programming language that you need to use. Therefore, I have prepared these factors that should help you choose which programming language that you need to use given your problem, or the problem that you want to resolve. So the following factors should be considered when choosing a programming language to use in solving a problem. 1. The availability of relevant translator. So you mentioned that with high-level programming languages, they are written in a vocabulary that is close to English, or with human language, and this is a language that the computer won't be able to understand. So we require language translators that will translate this language into machine language. So when choosing a programming language, you need to consider whether there is a translator for the language. So will the language be translated? Will there be a translator to translate this language to the computer? Because if the language is not translated, it will not be executed. So one of the factors to consider when choosing a programming language is whether there is a translator. The other factor to consider is whether the programmer is familiar with the language. So for you to be productive, you need to be well familiar with the program or with the language itself. So this will mean that you'll take less time in the programming process, and you won't make a lot of mistakes, and that will mean at the end of the day you'll be productive, because you'll make something that will be resolving problems within a very short time, and it will not even be costly because you have not incurred a lot of your time, you've not incurred a lot of resources. So you should be familiar with whatever programming language that you're picking. The other factor to consider is ease of learning and use. Of course, you need to pick a program that you'll be comfortable with. This is to mean because you won't understand everything at the word go. You need to be learning some new things with the program as you continue. So the program that you're picking should be in such a way that it will be easier for you to pick up new things in regards to that program, and it will even be easy for you to use the program. So you won't be failing to apply some things that are provided by the program language simply because you don't know that they exist. The other factor to consider is purpose of the program, that is application areas such as education, business, scientific, etc. So you find that different programming languages will be used to develop programs that will be used in certain areas. So you must know what problem you want to solve and where this problem is to be solved. Like, is it an education problem? Is it a business problem? Is it a scientific problem that you want to resolve? So it has or you have to know where this program, or in which field this program this problem is. So that will mean that you'll pick a programming language that will help you to resolve a problem that is in that specific field. So for instance, if you pick a programming language that is used in the scientific field, and the problem that you want to resolve is an education problem, you find that there will be some sort of incompatibility in, it will not be compatible, so there will be some incompatibility, and you'll find that you'll be having problems. The other one is execution time. So you find that with some programs, they might take, some programming languages, they might take a lot of time to be executed. So the program that you are picking should be a program that will be quickly translated and hence quickly executed. So applications that require quick response are best programmed in machine code or assembly language. High-level languages are not suitable for such applications because they take long to be translated and executed. So when, for example, you are designing programs that will be used by the hardware direct, so those programs that will be used by hardware's directly will require very short execution time, and in this case you might need to pick a machine code or an assembly language to write this program, because the machine code or assembly language will require little or no translation, and this means that they will be executed right away. So unlike the high-level languages, which will need to be translated first and then executed. So with low-level programming languages like machine code and assembly language, they are directly executed, and this will mean that the execution time will be lowered. The other is the development time. So the time a programmer takes to write a program. So you need to know, given some other factors like ease of use of of this program, how familiar you are with this program. So when you pick a program now based on that, it will automatically even bring the development time down. So the time that you are going to take to come up with a functional program will greatly depend on the programming language that you'll have picked. So if the programming language that you have picked is not familiar to you, you don't have the basic skills, and the programming language is even complicated, you find that the development time will be high, and at the end of the day you won't be productive. High-level languages are easy to read, understand, and develop, hence they require less development time. So as I've said, with machine code and the assembly language, they are difficult, like they are complicated languages, and for you to learn and start programming something sensible from them will require a lot of time. So to maybe resolve that or overcome that, you need to pick one of the high-level languages that are easy to learn and understand, and that will now require less of your time. The other factor to consider is popularity. So the language selected should be suitable and or successful in the market with respect to the problems to be solved. So you find that the program that you are designing will not just be used by you, it will be used by other people. So how popular is that language that you have picked? Because given the language that you'll have picked, it will also determine the end product, like how the program will look like. So will people be able to use this program to solve problems? So if the popularity of the language selected is down, then it will mean that the program created will also not be popular, and now people will be having problems resolving their problems with the specific program. So pick a language that is popular or that is successful on the market with respect to the problems that are being solved. The last factor to consider is documentation. So this is something that is very important in web development, I mean in programming at large. So documentation is whereby there is accompanying descriptions on how to use the language or maintain the programs written in the language. So you find that as I mentioned while we were beginning, programming is quite intensive, and it will require, or it will have a lot of things that will be required to be done. One of the things that should be there is documentation or descriptions or manual. This is like a description of how something should be used. And even with programming languages, just like with programs, like the program that you are going to design should have a documentation, like should have a guide on how it should be used. The same with programming languages. They will require descriptions, they will require guides on how they are supposed to be used. So when you are when you're selecting a programming language, you need to select one that has a documentation, that has a description on how it is used. So this will make it easy for you to learn. This will make it easy for you to pick up new things. This will make it easy for you to use the program, and at the end of the day it will increase your productivity. So those are the factors that you have to consider when you're choosing a programming language. Those are the factors that you have to consider when you're choosing a programming language. Now moving on, we have program development. Now that we have discussed what is a program, we know what is programming. We have discussed the various programming languages and the levels and all that. We can now start with program development, and this will involve stages that are involved in the program development cycle. So stages involved in the program development cycle. The process of program development can be broken down into the following stages. One is problem recognition or identification of the problem. Two is problem definition, and three is program design. So we are saying that when you think of developing a program, the following stages are the ones that you will follow. Otherwise, you'll develop a program that will not be useful. So when you think of programming any program, you should start with first identifying the problem to be solved by the software. The second stage is defining the problem. So first of all, you identify the problem itself. Two, you define that problem. And now three is program design. Now you start designing not coding, designing, and we'll be discussing this at length, where we will be using specific tools in designing that. The other stage is program coding. Now, after designing the program, this is like a draft. You have something in a paper or in another place. After that, now there will be coding, where now you'll be using the different programming languages, and you have discussed the factors that you have to consider when picking one. 5 is program testing and debugging. So after you code the program, you should test whether the program is working, whether it is solving the problem it was meant to solve, and you should also debug, that is remove errors. After testing, you're going to find that, oh, this is not working because of this, so you have now to resolve, find the problems and resolve the problems in your program statements. The 6th stage is program implementation and maintenance. So this is where now the program will be installed in computers, and people will start using, and as they continue using, there will be need for maintenance. This program is not working here, this one has crashed, 1 2 3. So what will now follow is the implementation and maintenance. And 7 is program documentation. So as I said, just like with programming languages that will require to have a description of how they are supposed to be used, the same case with programs. So after you develop a program, you need to come up with a description of how that program is to be used, from head to toe, like some sort of a manual or a guide on a step-by-step process or procedures of how the program is solving a specific problem. So those are the stages involved in web development, and we will be discussing each and every stage at a time because it is important. Starting with problem recognition. So this refers to understanding and interpretation of a particular problem. So interpreting and understanding a particular problem is what we are calling problem recognition. And there are 3 situations that can cause the programmer to identify a problem that is worth solving. So there are problems that are not worth solving. Problems or undesirable situations that prevent an individual or organization from achieving their purpose. This is a problem that is worth solving, because the dream of every organization is to achieve their aims, is to achieve their objectives, is to make profits. So if there is anything that is deterring that, if there is anything that is preventing that, then it is something that is worth solving. So, and if it can be solved by a program, then it is worth that program is designed to resolve that particular problem. Another situation is opportunity to improve the current program. So if there is a program that is currently in use but it is not successfully resolving the problem at hand, then there is need. It is worth to develop a program that will maybe come to resolve the problem that is with the current program. A new directive given by the management requiring a change in the current system. So management can still sit down, or directors can sit down and agree that the current system is not solving, or the benefits of the current program are not worthwhile. So we need to change the current program into a more productive one. So that is another situation that can make it possible for a development of a new program. So you find that this is the stage of problem recognition. So where a problem will be interpreted, where a problem will be recognized that, oh, we are having a problem with the current program, or we are having a problem that is, making us not to achieve our purpose. We need to, change the current system, yeah. So that will bring up the recognition of a problem. So the problem recognition refers to understanding and interpretation of a particular problem, as I've said, and the programmer must know what problem he or she is trying to resolve. He or she must also understand clearly the nature of the problem and the function of the program. So this is very, very important, and if you miss at this point, then the whole thing will become a mess. So you should know the problem that you are trying to solve. You should also understand clearly the nature of the problem, and this is at the point of problem recognition, and also the function of the program. So like, how will the program function to solve that given problem? And in order to understand a problem, look for the keywords such as compute, evaluate, compare, mention them. So usually a programmer identifies problems in the environment and tries to solve them by writing a computer program. There are three situations that can cause the programmer to identify a problem that is worth solving, as we have discussed, and that will include the problems or the need or opportunity to improve the current program, a new directive by management requiring the change of a system, and a certain problem that is causing the organization not to achieve a certain goal. So that is just some sort of a repetition of what we have discussed. Like, there's three situations that the program, or that can help the programmer to recognize a problem that is worth solving. So moving on to the next stage, that is problem definition or problem analysis. In problem definition, the programmer tries to define or determine the following: output expected from the program, inputs needed to generate the output information, processing activities or requirements, and kind of files which may be needed. So now that you have recognized the problem, the next step is defining that problem or analyzing the problem. And we are saying that in this stage, the programmer is trying to define or determine the output that is expected from the program. So every program will have, like, input, how it will process information, and the output. So at this stage, the user needs to know how output will be produced. How are we going to get the output? The other is inputs that are needed. For you to have an output, you need to have an input. So which are these inputs that are needed? So this should be defined at this step. Processing activities or requirements, and kind of files which may be needed. So are there files that will be needed by the program, or the programmer will need some files in designing or developing the program. So in problem definition, the programmer usually is like trying to analyze the problem. It's like trying to see how outputs, how inputs, how processing will be done. So let me just give you a sample problem that a user may try to analyze or define. So maybe you are required to develop a program that can be used to calculate or find the area of a circle, and you're told to use the equation pi r squared. So in given this problem, a user may be able to know or tell or define the expected output. Like when he or she inputs this equation pi r squared, it will be expecting a certain output. So like, what do I mean? Given this problem of solving the area, of finding or calculating the area of a circle, the user is required to input the formula, which is pi r squared. So that will be the input. The output expected, he will also be required to input some values, like maybe the diameter or the radius, or of the given circle. So those will be the inputs that will be required. And of course, the output that will be expected is the output of the formula, or actually the solution to that given problem. The programmer should write a narrative on what the program will do and how it is meant to achieve the intended purpose. Within this narrative, he or she is required to determine what data is to be input and what information is to be output. So just again going back to our example of calculating the area of a circle, the parameters needed to determine the area of any circle will include one input. That is, it will have the pi, the pi itself, which will be constant. So that is one thing that a user will need to calculate the area of a circle, the pi. Then the other thing that will be required is the radius of the circle, as I had mentioned. So the radius of the circle will also be required as input. The next thing will be process. The next thing will be process. And in processing, this is where the formula, that is the pi r squared, or all that, and the radius of the circle, that is the value that will be inputted. At step 2 of process, this is where now they be processed. This is where now the formula will do its stuff. So that now it calculates the radius of the circle. So at the stage of process, the formula for calculating area of a circle, which is pi r squared, will do its magic. And now the third step now will be output, where now the area of the circle will be outputted. So at the end of the problem definition, the programmer is required to write a requirements or report or a document for the new program. This document will enable the programmer to come up with a program design that meets the need at hand. So in problem definition, basically all you need to understand is the output that you expect, because again you have to have what you're expecting. Like when you are solving something, you need to know what to expect, so that you will even know whether it has been resolved. So if you don't know what you're expecting out of something that you are resolving, then you won't know whether you have resolved it. So in problem definition, you need to determine the output that you expect from a program. And again, you need to know the inputs that are required, like with the example that I have given of finding the area of a circle. You need inputs such as the formula. You need inputs such as the values that will be required by the formula itself. You'll also need to have the requirements that will be required in the processing activity, and of course now the kind of files that may be required, that is like the documentations that one will need to write in order to tell or narrate how the program is solving a certain problem. Problem definition should be done thoroughly to ensure user satisfaction and to facilitate the subsequent stages in the program development cycle. A failure at this stage usually results in a system that will not work as intended, or that may not work at all. So remember, at this step is where we are it's like the heart of the program. This is where you are putting the raw materials of the program. So if you input the wrong thing, if you expect the wrong thing, you find that at the end of the day the program will not work as expected. So this again should even take more of your development time, so that now moving forward, as you have mentioned, it will be easier for you, and it will even make work easy for you, because this stage is the one that will facilitate the subsequent stages of the development cycle. So it's like they are the ones that will complement the subsequent stages in development cycle. So if they are long, even the other stages, what you are going to have in the other stages will also be long. The other thing is problem design. And because I can see this is becoming quite long, our tutorial is becoming quite long, and I don't want to develop a long module for ease of understanding. I think we are going to have program design as our last thing that we are going to discuss in this module, and then we will be picking the rest of the stages in module 4. So program design is the actual development of the program's process or problem solving logic, called the algorithm. So problem design is the actual development of the program's process or problem resolving or solving logic, called the algorithm. So so the previous steps, or step 1 or stage 1 and 2 rather, were just meant to help you come up with a problem and define it. And now at stage 3, this is now where the actual development of the program is starting. This is where you are designing the logarithm. So the logarithm will be that thing that will now solve. It's like a formula that will be solving your problem. So it involves identifying the process. It usually involves identifying the processing tasks required to be carried out in order to solve the problem. It's important to note that to design programs before entering them into the computer, like it is important to design programs before entering them into computers. The programmer should only attempt to convert a design into a program code after ensuring that it is logically correct. If possible, check the logical order to the desk. So at this stage, we are simply saying that whatever you are designing should not enter into the computer yet. This is until you ensure that it is logically correct, like it is working. Should first of all work outside the computer before you expect it to work inside the computer. So program design is the actual development of the program process or problem solving, which we call the algorithm. And the design stage enables the programmer to come up with a model of the expected program, or a general framework or outline of how to solve the problem, and where possible, break it into a sequence of small and simple steps. The modules show the flow of events throughout the entire program, from the time data is input to the time the program gives out the expected information. So we discussed, or we've mentioned in stage 2, that you need to determine the output. So it is now at stage 3 of program design, where now you are like writing the algorithm of how the expected output will be outputted. So it's like you are designing a framework of how to solve the problem, and if possible, to break it down into a sequence of simple steps, that when you now come to program coding, you are going to code something that will follow those specific steps that are meant to solve a certain problem, or that will at the end of the day solve a certain problem. The processing task must be in order and systematic. So the processing task must be in a systematic manner. Therefore, the programmer identifies the processing tasks required and the exact order in which they are to be carried out. So that is very, very important to note. The design process does not take account of the programming language to be used in the final product, since it is only defines program logic. So in the program design, you're not actually using any programming language. Remember, this is just a framework. This is something that you can even be drawing on a wall, on a book, or somewhere. You can just be writing in the normal English. Maybe it will involve diagrams, it will involve other objects, but it will not be in a programming language. So having said that, then it now means that this stage does not take into account the programming language that you are going to use at the end of the day. So that is very important to understand that this is just a draft, this is just a framework that will just guide you when coding the specific program. Program design provides for easy maintenance. So now you find that when finally you come up with the program, and maybe at some point it requires some maintenance, someone can go back to the program design. So the program design, remember, is the one that is laying out the steps or the procedures of how the program is resolving problems. So if one now gets to the program design, he'll be able to see that, oh, the program is not doing this and that because this mistake was done here, this step maybe was skipped, or this step maybe is being repeated, or there is a problem in this step. So one now will be able to easily troubleshoot a certain problem that may occur. It is important to note that and I will repeat again that programs should not be loaded or should not be entered into the computer before they are considered to be logically correct. Some programmers produce live and ready solutions at a keyboard and continue to amend the programs until eventually the program appears to do what was expected. This is not recommended in programming because of the following reasons. The final code may not be easy to follow since it was not just cobbled together. Variable names and specific items of code may not be documented, and programs produced by continuous amendments and changing of codes mostly lead to unforeseen side effects. For example, they may not have been planned for testing the program or procedures, hence the program may easily fail. Another thing is that a programmer may be asked to modify the code at a later date. Without sufficient documentation, the programmer will be forced to trace through the program in order to gain an insight into how the program functions. So that marks the end of module 3. We will continue with module 4, where we'll be talking about program coding.